Welcome to part 3 of these Mesa tutorials. Today we are going to change the code a little bit so you can have a simulation of some fighting agents. It's nothing too fancy. It's just another example so you can build simulations and have the feeling of it, introducing some new parameters and some new flags and some new instance variables for the agents so you can handle all the situations. And with this tutorial I hope you can understand a little bit better how the simulations work and how you can do some simulations using the Mesa library. And of course, this is just a beginner level, so you can catch up quickly. Today, I'm not coding. I'm going to copy and paste the code and explain it, just to be more quickly and not bothering you with my typos. If you remember, let me run this. If you recall from the last video, we have some simulation where the agents share some wealth, and in the end you can see that we have some healthy agents and non-wealthy agents, and we are going to change this and we are going to have something like this. Let me run. And in the end we will have some different types of agents, type 2, type 1, and can be type 0 and type 3, and then we have this number that is the health of it, and then let me put that, and they will fight each other until someone wins. You can then even put a logic of a team of agents against each other. So this is the representation of a dead agent. This guy won the battle, kill this. So in the right side we have the new code, and in the left side the older code for the wealthy simulation. We are going to change it so we can understand how to do it. Let's go to the agent. We have more code now in the agent. Firstly, I already changed the name. Is not the money agent, is the fighting agent, and we can of course change the description. It's an agent that fights. Okay, so in the init method we are going to replace the wealth, and we are going to have some different kind of instance variables. Let me copy this. Okay, so we are going to have a type that we are going to receive that. Sorry, so the type is given when we instantiate a new object. We are going to have the health of the agent. Let me declare the variables here as well. So they are the global variables. The health, which will be 100. Then the attack damage for the agent by default is 50. And then if we were attacked, if we are dead and counting some steps, because I'm going to show the dead agents for 5 iterations and then we clear that up. And if you are buried, that is when you clear the dead ones from the visualization. According to the type, we are going to build different settings. Let me put this function here. I need to import the math as well. Basically, what this function does is, according to the agent type, we are going to change the health and the attack damage. By default, we have the global variables setting that. So by default, the health is 100. But if the type is 1, we have 200, the double. If the type is 2, we divide by 2. And if the type is 3, then we have a quarter of the health. And the same for the damage. So type 1 will have the double of the attack damage value, and then the type 2 will have just the attack damage divided by 2, and the last one will have 1/4 of the attack damage. So half, a quarter, and the double. You can do other kind of settings. This is just for demonstration, and then we need to change it. And as you can see, I'm giving room for different types. So if it's not 1, 2, or 3, it will have the basic configuration, because I'm calling this function with the agent instance only after setting the default values. We know that we have health, and you can attack, we can be attacked, we can be dead, and we can be buried. Where we are going to update these values, we are going to change the step and the move. So basically the step now will handle the flags. So let me comment this. And basically we are moving only if some conditions occur. Basically, let me copy all of this and remove this. Okay, if we are buried, we don't move. The step does nothing, okay? So buried agents don't move, do they? No. Okay, so we return. We simply pass this function for the given agent. If the given agent is dead by 5 iterations, by 5 steps in the simulation, then we bury him and return. Because it's dead, we just bury him and we move on. Now, if it is dead but not buried, we increment the count. So we want to wait 5 steps to bury the agent, and after that is dead, so doesn't move. Okay, return again. If we were attacked, we will need to wait a step until we will be able to attack again. So attack or move. We were attacked and we froze. We are frozen on that step. We cannot move. If we were attacked, we don't do nothing, and we change the attack to false because we just were there and did nothing. So the next step we can do something. Unless we were attacked again and you were screwed. Okay, and if nothing of this happens, so we are not attacked, we are not dead or buried, we can move. And the move is not only moving. Let's grab the code and give money. Okay. What happens here? So the move now is where the agent decides if it can move in the simulation for another cell, if he can drink the heal potion that will give him 20 of health, or if it attacks other agent. Basically here we can move, we can heal yourselves or attack other agent. Just a disclaimer, all the actions are random here, so we are only using random. If you want to have some intelligence on the agents, you can improve this, just updating the logic of being random. Basically, we are generating a random number between 0 and 100, and if it happens to be the number 1, we take the potion. The agent health will be increased by the healing potion value, and I'm printing saying drinking my potion, and we'll return. So if you drink the potion, we are not able to move to another cell or to attack. We drink, you wait for the next step, so you can decide what to do. If you don't take the potion, then we are getting the possible steps. We are getting all the cells around you in the neighborhood, all the cells around you. Then we are trying to identify if we have agents in those cells. In all those possible, let's change this to possible cells, or even better, available cells. The available cells in neighborhood, so you can move one cell in the diagonal or a random direction. You can move one cell basically. We want to check if there is an agent in the cell. Imagine one above you or below you, or on the right, on the left, in the right top diagonal, 1 or more than 1. So basically for each cell inside the available cells, we will get the cell list contents of that new cell and see if there is other agent. This returns a list, the get cell list contents. So we are going to see if the list has some length. If so, we have an agent there. And now we need to check if the agent is not dead. If it's not dead, then it's a possible threat for us, and we append that inside the agent that lives and exists near you. Basically, here we are going to get all the living agents around you. And now, if there is some agent on the neighborhood, we have some living agents, and we can have two strategies. Right now I'm using strategy 0 as an example, but it can be 1. If it is strategy 1, we can attack or move. If it is another number, we just attack. To have even more randomness, here we can have some agent near you and you just move around and don't attack, or you can have a strategy of always attack if there is an agent around you. Let's get the attack or move and attack. The attack or move will receive the list of agents around and the possible steps or the available cells. In this case, let me change the name as well. We will again use a random between 0 and 1. And if it is 1, is a truthy value, then we call the attack and give it the list of agents where we need to choose an agent to attack and then return. And by returning, we just skip, we end the move because we are right here, and we end the move execution and our step as well. If we don't attack, if the should attack is 0, then we say I chose to not attack, and we find a new position in the available cells, and of course we move our agent to the new position. It's the same as a basic move we have here, because if there is no agent to attack, we just move. And how is the attack method? Basically we receive the list of cells with living agents we can attack that are in our neighborhood of 1 unit of distance, and basically we randomly choose one agent to attack from the list of agents, and we change the health with the attack damage that our agent can do. That is different according to the type, if you remember, because we are setting that here. And we set that the other agent was attacked. That will impact here. You will not be able to move for 1 step. And also, if after attacking it, the agent to attack has the health value less or equal to 0, we simply say it is dead. We are setting that here as well. And if it is dead, you can see that it will increase the death count because it's not buried yet, but after 5 steps it will enter this condition and we will bury it. And you will understand what this will do when we go to the server. So basically this is all you need to have this logic. So new flags, new methods where you can implement some logic to handle how you attack or how you decide what you want to do, what the agent wants to do. If he wants to drink the potion, randomly decided, of course, and if there is some agent nearby, you can attack or move or always attack. It depends on the strategy. And inside the attack or move, you randomly attack or move. So it's a lot of randomness inside of this code. Also, the way we are moving the agent uses random as well. So the new position, it's a new random choice between the available cells. So a lot of randomness here. Now we need to update the model because we changed the fighting agent that now receives the type. So inside the model, when we are creating the fighting agent, we need to give it a type. And basically we are going to give another random, so a random range between 0 and 4, so we can have 0, 1, 2 or 3, and it will randomly assign the type of agent. We can have different type of agents. We also want to change the functions to collect the data. We no longer have the wealth, so we have the health instance variable. And so currently health agents, if they have health, and non-healthy agents if the health is 0 or if they are dead, basically. What we want to do, so if the current healthy agents are only 1, so everyone fought until just 1 agent remains in the simulation, then we stop the simulation, checking if there is a champion. And now let's get into the server. Here I'm changing these values so we can have a smaller number of cells, so 10 by 10. We are going to change also this class because it is now deprecated, and we are going to use the number input. Let me copy this and paste and import number input. So now we give it 10 agents by default. You can then control that. And now this is where we need to change some code. Let me also put here healthy and not wealthy. Let me copy the agent portrayal code. That will be way different now. We have buried agents, so we will create a portrayal with a white color that is the same color of the background, so they disappear. They are buried, we are not showing them. Then we set the default portrayal. The shape is a circle. Every agent is a circle. Filled by default, it's of the cell, the radius, and we will show a text with the health and the type of the agent, so we can see the type and health during the simulation, and the color of the text will be black. If the agent is dead, we will override some of the default configurations for the portrayals, such as the shape. It will be erect. The rect shape, we need to define the height and weight, and we will also change the color of the rectangle to black, like is that. So it's black and will be in the layer 1. Then we will have the layer 2 for the red ones, so they will be on top of the ones in layer 1 in the simulation. If you want to know which are the available shapes, you can go and see here. So you use the agent portrayal here. So if you open the canvas grid, you can see the shapes that can be circle, direct, or arrowhead, or even a custom image, and the description for what you need to include is here, like the rectangles need the width and height, and you can give the x-align and y-align that defaults to 0.5 to be in the center. Okay, let's recap. If it is buried, we do not show it by putting the color as the same as the background of the simulation, that is white. Then we set the default portrayal to then override some of the properties according to the type. If it is dead, we just change to a black rectangle, and we reduce the height and the width of it to be a little bit smaller in the cell by setting the height and width. And then according to the type, it will have a different radius. Type 3 will be almost the size of the cell. Type 2 will be a little bit bigger than half of the cell size, and you understand the proportion. Then if the health of the agent is greater than 50, it will be green. Otherwise, if it is less than 50 and it's not dead, it will be red. So I believe that we can now try to run it and see if I forget to copy and paste some code. Okay, so for some reason I have a different variable here, so let's try it again with the correct name, number agents, yeah. Okay, so we have our simulation. Now we have 10 by 10 cells inside, and we can see we have a type 3 agent with 25 of health, the type 0 with 100, and you can see that according to the types, the circle radius is different. Type 1 with 200 of health, and we have type 0, 1, 3, and also one of type 2 with 50 health. So if you start, they will randomly do things, and you can see the black rectangles as the ones that died, and after 5 steps they are buried. And now we have the winner with type 1, and this one is just dead and will be there for the eternity. And of course you can just put like more agents, reset, and put these like crazy fast and start and see how we're going to die again. So let me see. Type 3, this time 1. Okay, you can see you can experiment with that, and you can change the settings of the grid so you can only attack or get the cells and take into consideration the walls. You can do a lot of stuff here. You can also put this with more cells like 20 by 20, and by the way you can also see the prints like I attacked. And let me see which is the strategy that we are using. 0, so let me put 1, and it will have different strategy because it can move without attack the agent next to him. So let's put this running like hell. Go. As it is random, you can take a while to finish. Let's restrict the grid. This is the last one. Restrict the grid here to not allow navigating through the walls. And you can see that they are drinking the potions and they can choose to not attack, and they also can attack. Let me restart by saving, and now they are restricted to the walls. They cannot teleport from the left to right and the other way around. Let me start. Go. They are a little bit dumb because they are just randomly moving and randomly deciding if they should drink the potion, if they should attack, or if they should move even with an agent in the neighborhood. So of course you can improve the logic inside the agent. You can also have 2 types of agents. You can have, instead of having this typing, this type, so a class with different types, you can have a class for each one and handle the intelligence of it in different ways. And then here, instead of just creating fighting agents, you can create like 50 or 10% of the fighting agents, 10% of the total number of agents will be like the badass agents, and the remaining percentage will be the dumb agents. And you can show them with colors according to its class, and you know, the sky is the limit. And basically you can see that by just having some flags and a really dumb logic, you can entertain yourself and try to see a real fight. Let me put like 200 of them, and they will kill each other really fast. And let's see who will be the winner today. Come on. And hopefully it will not take my whole day. Come on, guys. Go. And you can notice that now they are restricted to the walls. Go. And let me see if they are drinking some potions. Meanwhile, yeah, they are getting more health, and maybe they cannot kill each other in the first place. Come on, they have the same type 1. Go. And this guy with 320 health won. Basically, this is how you can change the default tutorial from Mesa, from the Mesa library, and you can apply it to something that you like. Don't forget, I have an example from 2020 with the COVID simulation. The link is in the other videos, if I'm not mistaken, so you can also see the code. For today, that's it. I hope you enjoy it and that you are ready to build some really tough fights.